Very good evening to all of you, and this is Vikesh here, and welcome to our Valedictory program today. Hope all of you are fine and doing well. This is a final day and where we have come together. It has been 3 months journey, so I welcome all of you on behalf of Advanced in Geographical Research. It's a government registered under MSME and ISO 9000 certified 2015. What we have learned in these 3 months programs, as we all know it very well. So today is the day of all members, the research persons, Dr.JayantaDas, chief guest, Dr. Satyadal Paul, and we have got our special guest, Somik Bardhan today as well. In this 3 months long program on groundwater potentiality and the stage donations by using TOPSIS, VIKOR, EDAS models in ArcGIS, we have learned how to have something like, from scratch to actions, from A to Z, how to select the parameters and how download the raster and the vector data processing images, ArcGIS environment. Justification of our variable step-by-step guided by TOPSIS, VIKOR, and EDAS in Excel. So here, we are really thankful to Dr. JayantaDas, who has given his expertise in this long 3 months journey. At the same time, I especially thanks to Nourish to power this program, and I thank you all those participants, those who have learned in this long 3 months with us, and we have just got to know all about how to just make all those papers ready and to publish them. And some of our students, they have done it very beautifully. I will go at the end of the program to get their views, and they will show us some presentations as well, benefited from this course. You all about why we will learn from this. Step-by-step procedures from the data download, handling selections procedures, predictions of map, and to validations. And the comprehensive understanding of the TOPSIS VIKOR with the EDAS models. Dr. JayantaDas, who has given his knowledge or the share as his expertise, the way when we have all got is really praiseworthy. At the same time, I must tell about that. Whatever the problem we had during this course, all the time, and we have got him, has been very supportive. It's true. Whether it was over phone calls, in WhatsApp, in every way, he has been really supportive. I thank you all of you to be here once again. And I must tell you that today we have just come to a place and where and would like to take all of opinion and to establish and to share and to get to know. First of all, I would like to invite Dr. Satyadal Paul to be here. And if I say something about Dr. Satyadal Paul, who has been with us and in touch for many, many years, and we know him that in research in CZ, RCI, the solid phase on synthesis and the transparent ceramics, the senior lecturer in the chemistry, Darjeeling Polytechnic, and the assistant professor in chemistry, Bangavasi Morning College. He has done PhD in theoretical and computational chemistry and the magnetic molecules, developing emulations and computations of the magnetic parameters, and postdoc from Germany, Planck Institute of Chemical and Conversions. I am honored, I feel privileged to invite Dr. Satyadal Paul to be here and to share something about this platform.
Thank you very much for your kind introduction. I hope that I am audible to all of you.
You are audible, but you are not viewing. Yeah, right now it's fine.
Okay. Again, I would like to repeat that thank you, Mr. Convener, for your kind words. Yes, I have been long in this journey of the research. So I'm doing my research. I'm pursuing my research in theoretical and computational chemistry, and so it is very obvious that the topic what you have covered in your past workshops, I'm quite off from the topic. Though the method what you have adopted, like TOPSIS, VIKOR, and EDAS, where you actually parameterize or optimize some parameter uh, through the optimization of different multiple criteria, the method maybe perhaps I have adopted some similar type of model in my research. So when we have to, I mean, assume a particular wave function for a molecule, and through some iterative process, we have to optimize the method. So though the topic is quite off from my own research area or from my own expertise, but perhaps sometime at some point of time, I have actually exercised the technique, knowingly or unknowingly. And of course, I must say that these advances in geographic research has provided a wonderful platform for the aspirants from different fields of research and industry, and perhaps from the educational sector as well. Uh, and it has actually acted as a wonderful groomer, and it has provided a wonderful platform to develop the expertise on these methods, and provided and familiarize them with state of the art instruments, state of the art tools, so that they can grow their um, own expertise on this field, which will develop, of course, in their profession, upcoming profession. So uh, that much, that much, what comes to my mind at this moment. And after this, uh, I would like to finish my talk over here, and I would like to hand over the thing to convener again.
Thank you so much, sir. Thank you so much for your lovely words. And obviously, your words are going to encourage us and encourage our participants. And really, and it will help us to know better. And we will be learning and we will be in touch with you, sir. And thank you very much, sir, for coming here and to join us and to share your knowledge and expertise in this platform. Thank you so much, sir.
Thank you. You too.
Now, I would like to call Dr. Somik Bardhan, who has initiated his research career from Central Glass of Ceramic Research Institute, Kolkata, on the preparations of the high temperature resistance coating for the aircraft and the missiles. Thereafter, Dr. Bardhan did his PhD under joint guidance from Indian Statistical Institute of Kolkata, University of North Bengal. Dr. Bardhan has long postdoctoral experiences from IIT Madras, which is the #1 academic institute of India, and it is quite known to all of us. At the same time, I must tell you that he has researched and received several awards, fellowships, like national postdoctoral fellowships, and he has got a lot of recognitions as well. So here, I would like to call Dr. Somik Bardhan sir. So Somik Bardhan sir, please come up and please share size and the knowledge with us. And please.
Thank you, convener. So am I audible and am I viewed right?
Yes, sir. Yes, sir. You are.
Thank you very much. I got invited from Advances in Geographical Research. So I feel proud for this, and also I've been surprised when I received the invitation, because in this long 20, near about the 2 and 3 years pandemic situation, we all are in the home. However, how can we utilize this time to learn more? That's what we have required such a platform, so we can utilize our time to explore us for various different areas, like what they did last workshop, like groundwater potentially, and the stress zonation using different methodologies. So when I see the workshop there, I've been surprised, and I also thought that it could be possible that I can do something for the student, because this is a very good platform for teaching and both learning. So not only the official dignitaries participated in this platform, first of all, I would like to thank all the participants of this workshop, because after that they will get the certificate and all this stuff. Hope they will get some different knowledge by which they quite able to make paper, because I have my 26th research journal at international paper. Hope that such a way the students or the participants who are join with us, they also encourage and do at least 1 or 2 research paper by utilizing the knowledge they have received from this workshop. In my way, near about the 1st of February or middle of February, I would like to announce in this platform that I will go for another workshop based on the Origin software. Origin is the data analysis and the graphing software of choice for over the 500,000 scientists around the globe and engineers. Origin has also been used for different government laboratories also. So Origin offers an easy to use interface for beginners who will come for the system, because Origin will give us the platform for data visualization only. So how could you visualize our data? Different software are there. Excel is there, MATLAB is there, Origin is also there. But what is the specialty of the Origin? Yeah, indeed, because Origin can be embedded with the MATLAB, with the Microsoft Excel, and create customized graph as per our requirement. Not only that, Origin also perform advanced customization of you to become more familiar with the applications. You take your data and analyze to next level with not only Origin. That's what people have been writing. Right now we use Origin Pro. Origin embedded with Origin Pro software will give you much more advanced analysis, like the peak and the application of peak, or if you have a multi-peak, how could you analyze this? For if you have scattered data, how could you analyze this? For you have a round shape or the figure or map, or you have a contour diagram, you can use Origin software and you will have the beautiful graph or data visualization within a second. That will, I will teach this, or I will start my workshop in coming February. So right now I'd like to invite Dr. Satadol Pal, our chief guest, to say something, his own experience on Origin. Dr. Pal, please.
Okay. So I hope I am audible and visible again.
Yeah.
Okay. Thank you, Dr. Vardhan, for giving me some chance to speak on the advantages of Origin and the features of the Origin. So, in my total research career, of course, I have found Origin as a wonderful tool to handle intensive data. So, being a computational chemist, while working on the different molecules, when I am running different jobs, different codes, different programs on a molecule, I'm getting huge amount of the data. So at the end of the day, this becomes our duty as a computational chemist to analyze those data and to reach some meaningful conclusion. And for a human being, it is almost next to impossible to go through these 100,000 of the data and to analyze them. So we must have some expert at our facility who will do this thing for us. And Origin is this kind of a program, and there are similar type of programs and well-known programs like MS Excel is also there. That also does the same thing. And in the same line, we find different mathematical programs like MATLAB is there, Scilab is there, and Dr. Vardhan said Origin is of course there, MS Excel is there. So the people can use all these programs, all these softwares to analyze this intensive amount of the data, innumerable data, and get a trend out of this, to reach a trend out of this 100,000 sets of data. As I have understood, the participants who will be given the certificate in this valedictory program, of course, they have went through a very useful program on the groundwater potentiality and the stress zone, and they must have come across a different type of the criteria, and they must have come across a different type of the data, and gradually they have to analyze those data to reach the conclusion. And Origin can be the best in this work. So in my research career, where I have used Origin, I would like to cite a few examples where I have used Origin extensively. As I said, when I have say 2 different sets of data, and we get a linear plot from some experiments. And I am a theoretician, so I do calculate the same data, but by some different means, by putting into by solving some formula, by solving some equation. So I'm repeating that I have a set of the data which comes from the experiment, and me as a theoretician, I have calculated those data by using some equations. So I have these two sets of the data. So how close they are, or how good my equation is, that I can know by looking at the similarity of these plots. This is the experimental plot, and this is the calculated plot. And that's why I have frequently used that linear regression formula, which is there in the origin, and we get this R square value, which is known as the dependent variable, uh, and we put it into the linear regression formula. So higher will be the value of the R square, better is the match between the observed set of values and the experimental set of values and the calculated set of values. And and in other instances, I would like to cite another example. In Lately, in my postdoctoral career, I've been engaged in the reactivity of the different molecules. So when a molecule reacts, some bond breaks down and some chemical bond forms. So actually, a reaction is a phenomena of multiple bond breaking and multiple bond reforming. So what happens? The molecular energy that changes abruptly when some bond is getting twisted, it's getting broken or getting rejoined. So if you want to get the energy surface, that how does the energy of a molecule is getting changed when the reaction is actually happening, then you have, if you want to track the changes in the energy, uh, so you have many variables. So in one column, you will have the energy. In the second column, you will have the different bond parameters. So you want to suppose, so you have a different, say 10, say 5 to 6 columns of different variables. X is one variable, another is y1 variable, y2 variable, y3 variable, y4 variable. So I have a 5 different columns of the variables, and I want to plot all of them in a single plot. So it is extremely difficult, and at this point, origin comes out to be very handy. I must say that when you have this kind of the data, where you have a different set of variables, you can easily plot them. And the better part of it is that you can make the different variables more distinctive, because origin has a very beautiful feature of assigning different kind of shapes, different kinds of colors to different plots, to different variables. So you can monitor or you can track the changes of all the variables by little play with our origin. And of course, it is very user friendly. It doesn't take a lot of time to learn it. And I have entire belief that Dr. Bordot in the February, he can familiarize the participants of the forthcoming program in a much better way with the origin, and so that the participants can befit them with the job requirements or the career requirements. So that much I have to say regarding the utility of the origin in your career. And now it's over to Dr. Vardhan. So I would like to finish my talk by thanking Dr. Vardhan once again.
Thank you, Dr. Paul, for your very good introduction about the origin handling and all this stuff in your research career. So right now, I'd like to invite Saurabh Nandi. Saurabh Nandi is a final year PhD student of IIT Kharagpur. I'd like to invite Saurabh to say something about his hand-on experience on origin. Saurabh, please share your hand-on experience on origin.
Am I audible?
Yeah, audible.
So thank you, Dr. Vardhan, for inviting me. It's a nice workshop going on, I can see. So considering the introductory workshop, this one, so let us first, let me introduce why do we use origin. And origin is a platform for who? Nowadays, people can assume that it is not only asset to research scholars or any master degree students, but you can see that this platform is being also used by college level students, graduate students. So why do we need the origin? Suppose one went to a market, got 100 rupees, he spent 100 rupees and got a bag of apple, let's say. Next day he went to market and he spent 200 rupees and got 2 bags of apples. And in the same way, let's say when he spent 1,000 rupees, he got 10 bags of apples. So when we plot, you can see that there is a trend, that number of bags versus the amount of money you spent. So when you plot this, you will get a nice curve. So now if one asks you that what when you spent 175 rupees, what when you spent 179.5 rupees. So to get an exact and accurate picture of whatever you are spending against what you are getting. So that's why we need this platform. That means it gives you every minute detail of your data. So here, just for example, I'm giving you a scenario of apple versus money. So this is the same for any experiment. So whenever we are doing some experiment, we are giving some input. Let's say you have taken a water in a test tube and you are hitting. So as you are increasing the temperature, let's say, as you are giving more time to the to this test tube, your temperature is what is the outcome? Your temperature is increasing. What you are giving more time to heat the water. So in experiments, we give one input and we are getting one output. So to get a relationship between the input versus output, we need this origin sorter. Now, in higher studies like research, why do we need this one? So one of the best example of this is the deconvolution of the data. What is meant by deconvolution? Let me introduce in a very crude way. Suppose in this COVID scenario, you take 3 or 4 states. Let's say West Bengal, your UP, Bihar, and let's say one more state. So suppose we want to see how the number of COVID cases are changing per day. So suppose we want to see the trend over last 6 months. So what we will see that when we consider these 4 states, we'll see that at the initial stage, the number of cases were increases, and at a particular time that got a peak position, and then it got decreased. Type of a very rough Gaussian distribution you can see. But is it the case that in all these 4 states follow the same Gaussian feature of this COVID case? No. So that's why when we see these 4 states from a top, then only we will get such a Gaussian distribution. But if I see the individual these 4 states, let's say now we assume West Bengal separately, then UP, then Bihar separately. We cannot get, in fact, in practical, we might not get such a Gaussian distribution. That means what? That whenever I am disassembling a particular information, then I am getting some individual and separate information. So when I am assembling this all the COVID cases of all these 4 states, I'll get a single distribution. But whenever I am disassembling the information, I am getting 3 different type of information. That number of COVID cases in West Bengal is this, and UP is this, and let's say for Bihar is this. So this to get information from a single point to a multiple number of peaks. Peaks means any information that you want to get. So that we can do using origin. So the technical term is called deconvolution. In the upcoming series, we can see some sort of practical examples how deconvolution is being done. You can see some nice videos uploaded by Dr. Bardhan also. Another one. So let us get back to the example of apple. So I got a very simple example that you spend 100 rupees and you get 1 bag of apple. You spend 200 rupees, you got 2 bags of apples, and so on. But suppose one day you get 1 bag of apple at the cost of 100 rupees. Suppose next day you got one bag of apple at the cost of, let's say, 125 rupees. And in the next day, you get a bag of apple at the cost of 200 rupees. That means you are not getting a linear trend. So that means you are getting a trend, but that is not linear. So whenever you are getting such sort of information, what is the equation? I mean, what is the best equation by which you can describe this phenomenon? That also you can get an idea from the origin. That means you have to write some input variable at that software. We will discuss in the upcoming series, and then we will try to fit by a number of equations, and then we will see that what is the best equation by which we can describe this phenomenon. Another one is that whenever we are doing some experimental study, we usually get a numbers, I mean, 1,000 to lakhs, millions number of data points. So you, in some of the cases, whenever you see the trend of data points, you can see that those data points are not actually following some regular data set, regular data trend. So there you visualize that some of the data are actually deviating from the line. That means those are actually scattering that data. So those scattered data you can also delete. I mean, that is called smoothing. So that also you can do via origins. So that means, so whenever I am getting a millions of data and supposed to get a very nice trend, then I can delete some of the scattered data to get a smooth plot. So that means the visualization of data, I mean, good visualization of data or smoothing of the data that I can do from origin. So all these things, we can see the application of these things in the upcoming lecture series. With that, I am leaving this to Dr. Vardhan, and if you have some question, I am here to answer, or else in the next upcoming series, I will discuss about the practical implication of origins. Thank you, Dr. Vardhan.
Thank you, Saurabh, for your what you are doing, that sharing your own in-hand experience with a very simple example. Thank you very much.
Thank you so much.
Good night, all.